So yeah, everyone please switch on your videos. Anushka, Mohammed, Anisa, Safreen, Vamika, Imangi, and Akshaya. Switch on your videos. Okay. So we are gonna discuss the concept of light. So starting off with the very basic thing, that is, sir, I'm not feeling well. So, okay, no worries. So starting off with a very basic concept, that is luminous or non-luminous. If I am talking about a luminous object, so that is an object which is what, creating a light of their own. For example, sun can create a light of its own, that's why it's a luminous object. Whereas non-luminous object like wood, it cannot create a light of its own. We can see it because it's simply reflecting someone else's light. Yeah, we can have few more other examples as well. Any shiny object as well, it is shiny because it is just reflecting light, it is not creating a light of its own, so that's why it's a non-luminous. Similarly, moon also reflects the light of sun, it is also non-luminous, and this is a luminous body because it is creating a light of its own. Very easy. Next is transparent body. A transparent body is a body which is allowing all the light to pass through it. Majorly we talk about glass. So a glass allows 100% of the light, or we can say most of the light, to pass through it. That's why it's transparent. Next is translucent. So anything which partially allows the light to pass through it. Even if you take a bottle, water bottle, which you actually buy a new bottle, so it's very shiny, it's very clear at the start, but slowly and gradually it starts getting scratches on itself, and it becomes very scratchy, and then it becomes translucent. So when you buy a new bottle, it's transparent, but slowly it becomes translucent. Okay. Last thing is opaque, anything which completely blocks the light to pass through it, that is example of a opaque object. Okay. Next is ray or a beam of light. So when we are talking about ray of light, it's actually like, let's start off with beam of light. So whenever you open a torch and you see the light going like this is actually a beam of light. But over here in this chapter, we cannot draw beams like this again and again. It will take a lot of time. So to save our time, rather than making beams again and again, we will make rays. So rays are a simple implication of where the light is traveling. We can clearly see the light starting from here and going in this direction. Yes or no? Yeah. So we can easily understand right now that how the light is moving. So we'll be using rays a lot in this chapter. Can I move ahead? Is this part clear to everyone? Is this clear?
Yes, sir.
Yes. Fine.
Yes, sir.
Next is reflection of light. So reflection of light is also a basic topic. That is, whenever the light bounces, whenever it is bouncing back from a polished surface, that is what reflection is. So we see our reflection in water, in mirrors. This is a reflection of light. Very easy. When we talk about laws of reflection, so the first law is all about So the first law is all about that whenever a light is sent, it is hitting a mirror, then it gets reflected. So during that procedure, if you actually draw a normal, that is, this is the incident ray, this is the reflected ray. And if you draw a normal means perpendicular to the mirror, then this angle and this angle, they will be equal to one another. Okay. Angle of incidence and angle of reflection will be equal to one another. Just give me a minute. Okay, I'm back. So this is the first law, that angle of incidence and angle of reflection. Then the second law says that the incident ray. Am I clearly audible, everyone? Am I audible now? Hello.
Yes, sir.
Yeah. So the second law says the incident ray, the reflected ray, and the normal, they all lie on the same plane. They always lie on the same plane. It's like a proper explanation to it. You will understand if you will actually see how this actually looks like. Imagine this is an incident ray coming on my hand like this. So of course the reflected ray will go like this. I think this makes sense. And there will be a normal like this. The reality is the same plane means they will always look like this. So when I'm seeing black from one side, which is, yeah, so you will see all the others are all automatically hidden. Why? Because they are lying on the same plane. Although they exist, everything is existing right now. Yeah. But why is it hidden? The reason is quite simple, because they all lie in the same plane. Incident, reflected, and normal. Okay. Yeah. Next is a plane mirror. So when I'm talking about a plane mirror, how the image is getting formed over there. So this is a plane mirror. We place an object like this, and what do we call that? This is the ray going like this, and this is the incident ray. It gets reflected back like this. Very simple. Okay. Now this is the second ray. It gets reflected back like this. Fine. Now you can clearly see that the first ray and the second ray, they can never be like, they can never intersect. So if I want them to intersect, what will I do? I will extend it in the backwards direction. I will extend it over here in the backwards direction. So if I will do it, my work will be done. You can clearly see that because they cannot, yeah, because they cannot intersect, I am extending them in the backward direction, and here is the formation of image. So just like in reality, the image is formed inside the mirror, over here as well, the image is formed inside the mirror. Yeah. Diagram is clear, everyone? Is that clear? Next. Next is the properties. Properties are also very simple. The image is virtual and erect. Erect actually means that if your head is up, leg is down, and if you stand in front of a mirror, then the reflection will also show head up and leg down. That's it. Okay. Now, second thing is, this is what you see in a plain mirror. You will never see something like this. So this is inverted. You will not see this. You will see a erect image. Second thing is virtual. Virtual actually means that the image which you see in a plain mirror, it's actually what? A illusion. Virtual means it's not real. It's illusion. Whatever you see inside a plain mirror, is it real? What do you think? Is it real? The answer is no. It's a false. It's not a real image. Yeah, it's virtual. It's not an illusion. You cannot touch it. You cannot feel it. You can't do anything with it. Clear? Is it making sense? Is that clear, everyone? Yeah? No. Next thing is size. So the size of object and the size of image is always equal. If your height is this, then the height of image will also be the same. Exactly same. Next thing is that the distance from the mirror, if this is the mirror and this is the object, then what can we say in this situation? The distance between object and mirror is, it will always be equals to what? The distance between mirror and the image. If this is X, then this will also be X. Always keep it in mind. Fine. Yeah. Last thing is lateral inversion. So if you see your name in a mirror, you will always see it to be inverted. So it is always inverted, signifying that it is literally inverted, and that's why the name of a ambulance is always written like opposite like this. Because if you will see it in your own mirror, you will see it to be like this, proper. That's why it is written, and you can now, when you see it, you can move, you can leave ways for it. Okay. So the next thing we have to discuss is, yeah, it's a difference between the real image and a virtual image. So when I'm talking about a real image, in a real image, you will see the rays are actually intersecting. So imagine this is ray 1 and this is ray 2. They will be actually intersecting in a real image. But when we talk about a virtual image, this is the example of a virtual image over here. Yep. And as you can clearly see, are they actually intersecting? No, they are just appearing to intersect. Yeah, they are intersecting on the other side. That's why this is a virtual image. Okay. Real image, if I'm talking about, it can always be obtained on a screen. You can always obtain a real image on a screen. That's why when you go in a theater, you see anything, it's using a projector, that's a real image. Virtual images cannot be projected on a screen. Whatever you see inside a mirror, can you project it on a screen? No, because it's a virtual image, not a real image. Yeah. Last thing is, it is always inverted, just like whatever we see. So whatever we actually see with our eyes, it is always inverted. Like whatever, if I am seeing you guys right now, the actual image is formed on the screen of my eye, and it is inverted. Although the brain fixes it, but it is inverted. Whereas the virtual image is always erect. Yep. And these are some of the examples over here. Is this clear, everyone? Fine. Clear?
Yes, sir.
Yeah.
Sir, the first example for the virtual image, right? The one with the TV. How is that
This is
virtual?
not a TV. This is actually, oh, this one you are asking?
Yeah.
Of course, it's a virtual image example. Yeah. Next is spherical mirrors. There can be two types of spherical mirrors. The first one is a concave mirror. The second one is a convex mirror. A concave mirror or a convex mirror you can easily see in a spoon. So you can easily see in a spoon. Now, this part of the spoon, which is like outside, it's behaving like a convex, and the inside part is behaving like a concave. What?
अभी नहीं देना चाहिए था, तो वापस लेना पड़ा.
So now we will not be talking about ray diagrams. That's not important, but we will talk about some uses. Oh yeah, this is more than. Yeah, there are actually a lot of different topics over here which is mentioned. But of course, for now, we will be discussing only the levels which are like for your school level so that you can do it properly. Yeah. So let's discuss few questions over here. If anyone wants to answer, you can. Okay. Question number 1. Suppose can you see the objects in a room? Can you see the objects outside the room? Explain. So anyone who wants to answer the first part of the question. Can you see the objects in the room?
No.
No, we can't see the objects because, see, imagine if you want to see anything that needs to reflect light. But if there is no light, what will it reflect? Yes or no? So if it will reflect nothing, you will not be able to see it. But will you be able to see the things outside the room? Yes, you can, because outside there is room. Outside there is what? Light. Yeah, it's like kind of sitting in a dark room and there is a small hole which is showing off light. It's like that. Next is the differentiation between a regular and a diffused reflection. Okay, I will show it to you. Wait.
So regular reflection is the proper reflection. The diffuse reflection means the wavy reflections
Yeah, exactly.
on the cardboard.
So if I'm talking about a regular reflection, this is how it will look like if you have a proper plane surface. Yeah, if you have a good plane surface, then what do we call? This is how the reflection will look like. Very easy, very simple. Okay. Now, if you have a irregular surface, like even when I'm talking about water, so when the water is very calm, very still, so it will have a regular reflection. But when the water is like not very calm, it's like very haphazard. In that way, it is still doing reflection, but it is irregular reflection. Okay. Nice. Next question. Mention against each of the following whether regular or diffused reflection will take place when a beam of light strikes.
Sir, what about the second question, second part?
Oh, does diffused reflection means the fake? Yeah, okay, I'm really sorry. Yeah. Even there is. So the question is asking, does the diffused reflection mean the failure of the laws of reflection? Answer is what? Yes or no?
No.
No. The answer is no. Even if there is actually a diffused reflection like this, but even over here, the laws of reflection are properly followed. Reason? The reason is, let's talk about this particular reflection, for example. Let's talk about this one. So if I see this one, then what's going to happen? The normal in this condition will be like this. This is actually the normal, because normal means perpendicular to surface and the surface is irregular. So there will be different normals. And if this is the normal, now you can see angle of incidence and angle of reflection are clearly equal to 1. Yep. And similarly, we can make different normals for all of them. Are you all understanding it? Yes. Is it clear? Okay. Next is, you guys can raise your hands if you want to answer. So which one will do a regular reflection? I will give you one example. That is, mirror will do a proper regular reflection. But what about others? If you want to answer, raise your hands quickly. Polished wooden table, regular or irregular? Yasir.
Sir, regular.
Regular. Cardboard surface, Anisa.
Sir, irregular.
Irregular. Chalk powder,
Sir, irregular.
of course it is irregular. Anyone else can also answer. Marble floor with water spread over it. Yes, Anisa.
Sir, regular.
Regular. And a piece of paper, Himangi.
Irregular.
Irregular, exactly. Next is state the laws of reflection. We have already learned it. Describe an activity to show that the incident ray, reflected and ray all lie on the same plane. I just gave you the activity. I explained that to you. So you can actually do it at your home. It's not a very big deal. This is also an activity. Yeah, as you can see. So this is also an activity that if you don't have source of light like this, you can use a laser light. And you will see that incident ray, reflected ray, and the normal all lie on the same. So this is also an activity. Next question. Who wants to answer the fill in the blanks? You can raise your hands. Okay. A person 1 meter in front of a plane mirror seems to be dash meter away from his image. Himangi.
Sir, 2 meters, cause
2 meters away from his image. Exactly. See, this is the mirror, this is the object, and this is the image. Yeah, this is object, this is image. So if the distance from here to here is actually 1 meter, the distance from here to here will also be 1 meter. So the total distance from here to here becomes how much? 2 meters. Okay, fine. If you touch your dash ear with your right hand in front of a plane mirror, it will be seen in the mirror that your right ear is touched with what? Who wants to answer? You can raise your hand. Yes. Yasir, you can answer.
The first one is left ear and then
If
touch
you-
with the right hand.
Yeah. So you can like basically if you touch your left ear with the right hand, then it in the mirror it will be looking like that you are touching your right ear with hand.
Left
Yes or no? Everything will be simply laterally inverted. Yeah. C part. The size of the pupil becomes. Now, what is pupil? This we have not discussed, so I will quickly tell you. So when we are talking about the human eye, in the human eye, we have one thing which is known as the pupil. Here it is. So the pupil of the human eye looks like this. The black part over here. Yeah. So this black part is the pupil. And what is the function of the pupil? So it becomes smaller or bigger according to the situation. That is, imagine you are talking about a bright light. So when we have bright light, then it will automatically become small. And if you have what dim light, then it will automatically become what? It will automatically become bigger. So it actually changes the shape, or basically it will automatically change the size of the pupil. Yeah, it will automatically change it. How? Just by increasing by increasing the size or decreasing the size, we can change the amount of light entering into the eye. Okay. The question is, the size of pupil becomes dash when you see dim light. So will it become smaller or bigger? Let me ask Anushka.
Sir, it becomes bigger.
Exactly. Because in dim light, already the light is less. So what will happen? It will try to become as big as possible so that more amount of light goes into the eye. Now, night birds have dash cones than rods in their eyes. Now, what are rods and cones actually? So when we talk about the retina, so of course there is a surface which we actually say that this surface in the eye is actually the retina. It's behaving like a screen. So on that screen, we actually see the image. But on that, there are actually two types of cells present, the rods and cones. So rods are something which which actually help you in responding to low light. Okay, they help you in responding low light, whereas cones respond you in high light. Okay, Like if there is high intensity of light, then we have cones. If there is low intensity of light, then there is rods. Okay. So now the question which we were discussing. If I am talking about the night bird, so what do they have? Big rods or like more rods or more cones?
More rods and less cones.
Exactly. They will have less cones. Why do they have less cones? Because like rods are helpful in dim light, which is at night time. Cones are helpful in bright light, which is daytime. Okay. It doesn't mean that one is less helpful than other. Both are useful. Okay. Now, new people, please raise your hands, or else I will talk to you. Oh, Mohammed Muksit, are you new?
No, sir, I just joined for the revision
Okay.
from
So
like when it started
seventh
revision
question.
class.
Okay, seventh question. Angle of incidence is equals to angle of reflection. Never, sometimes, always, under special conditions.
Always.
Always. So angle of incidence and angle of reflection are always equal to one another. Okay. Namrita, image formed by a plane mirror is it real or virtual? First of all, is it real or virtual? Hello, Namrita, am I audible? My audio isn't working. Okay. Maruf. So Maruf, image formed by a plane mirror, is it real or virtual?
Sir, it's plain mirror. Sir, it's virtual.
It's virtual. So of course, these two options are automatically deleted. Now, is it enlarged or is it the same size of the object, Maruf?
Sir, the same size of the object.
Same size. And that's why the option B is the right answer. Okay. Next is the construction of a kaleidoscope. Let's see it. So what is kaleidoscope actually? So it is something like a triangular shape like this, which is properly covered with cardboard from the outside, and it has mirrors on the inside. In reality, it will look like this. Yeah, it's not necessarily to be triangular. I can show you any other shape as well. Yeah, so it can be like this as well, covered with cardboard from the outside. But why is it special? Because if you will see inside it, you will see a pattern, something like this. Okay, very big one, but you will see a pattern like this. Yeah, so you can clearly see a repeating pattern right now. Yeah, something you might have seen in Doctor Strange or something. But how is it basically formed? Because there are multiple mirrors. So because there are multiple mirrors, so we see multiple reflections happening. And because of that multiple reflection, we see a pattern like this. So it's not very like something which is like very hard to make or not. It's very easy. Okay. Now, next is draw a well-labeled sketch of a human eye. Now tell me how many of you think that this is a tough diagram to make. I think it is easy. In this one, you don't have to make the aqueous humor. You don't need to mark this. Okay. And vitreous humor. This. If you don't need to mark these two things, is this diagram clear to all of you? Like, can you all make it on your own? Yeah? Yasir, yes, and you want to ask something? No? Okay. Next is Gurmeet. Now you guys can raise your hands. Gurmeet wanted to perform the activity 16.8. Okay, leave the activity part. Explain how can you take care of your eyes? Okay, this is a very important question. How can you take care of your eyes, everyone? Don't watch the screen for a very long amount of time. Like me, I see my screen for a very long amount of time. Yeah, so it's not good. Try reducing it as much as possible. Try giving as less screen as possible. Don't watch the sun directly. Okay, properly clean it or something. These kinds of things are very okay. Next, the angle of incidence of a ray if the reflected ray is at an angle of 90 degree to the incident ray. The question is, okay, everyone please give me the answer to question number 13 in the chat. See, the question is, what is the angle of incidence of a ray if the reflected ray? So the setup is something like this. So this is the reflected ray, this is the incident ray, and if this is the normal, the total angle is 90 degree. Total. This is what they are asking. Then automatically the half will be 45, other half will also be 45. Yeah. So if you will read the question properly, the reflected ray at an angle of 90 degree to the incident ray. So if total is 90, half will be 45, which is the angle of incidence as well. Okay. Next, how many images of a candle will be formed if it is placed between two parallel plane mirrors separated by 40 centimeter? Okay. So yeah, if you have two parallel plane mirrors, one mirror, another mirror, and you have the object like this. So how many images will be formed according to you?
Two.
Infinite. It will be infinite. Okay. So you will see a reflection here, then here, and now the reflection of this here and here. Like it goes on and on again and again. So it goes on and on and on and on. And you see infinite.
When light is placed or from an object.
What?
When a light is when an object is reflected into the mirror, infinite images can be formed, right?
Yeah. I will show you. I show you. There might be a diagram to it. There is no diagram, but no problem. Like, yeah, of course you have you ever visited the barber's shop? Basically a salon. In salon, when you sit and there is a mirror in front of you, at the back of you, how many images do you see, Yasir? How many versions of you actually see?
Infinite.
Infinite. That's the whole thing. Okay. Next is two mirrors meet at the right angles. Okay. So this particular angle is now the ray of light is incident on one at an angle 30 degree. Okay, draw the reflected ray. Now I can't ask you to draw it right now, but tell me, if I draw it like this, it will get reflected. This is the reflected ray. Who will tell me that what angle is this? How much angle will be here?
30.
It will be 30. Anyone else as well, please give the answer and it will again get reflected. So first of all, if this is 30, then it will automatically be 60 remaining angle. And if this is 60, then this will automatically be what? 30 again. Are you guys understanding what I'm saying here? Yes? Yeah.
Yes, sir.
And if this is 30, then finally again this is 60 and this is also 60. Okay. Fine. Now the question is, Bujo stands at A on the side of a plane mirror as shown in the figure. Can he see himself in the mirror? So if the mirror is till here only, so can he see himself? Give me the answer, everyone. Answer for this part.
Yes, he can.
Of course, no. The answer will be no, actually, because right now there is a mirror. I will show you a proper example. Yeah. So there is a mirror right now in my hand. Yeah. So if I take this mirror, I put it in exactly in front of me like this, then I will be able to see myself. But if I place it on the right, you might not be able to see it, but it's right now here on my right. Like this. This is mirror. I'm taking on right. Can I see myself now? No, I can't. But I can see something else as well, which is like over there or something else I can see. What is the methodology actually? Yeah. So what do we actually do to make this? If you will see, this is the mirror only, like this is small mirror. And now clearly the mirror is not in front of A, not in front of A. So now he cannot see himself, first of all, but he can very easily see P and Q. Why? So if P is at a distance of X, then the image will also be at a distance of X. If Q is at a distance of Y, then image will also be at a distance of Y, and same goes on with what? If R is like Z, then this is also Z. Now,
Sir, are you sharing the screen?
oh, I'm not. Oh, I'm really sorry. I'm really sorry. Oh, I will speak again. I'm really sorry. Okay, is my screen? Hello.
Yes, sir, it's visible.
Yeah. So as you can see, the mirror is over to here. Okay. So this part of the mirror, like there is no mirror here. So A will not be able to see itself. So it cannot see itself, but it can very easily see P and Q, because the image of P, the image of Q are actually having a straight line, passing through the mirror. And because it is passing through the mirror, they can easily see it. But what about R? Can they see R? Now, if you will join it, it will go like this. So yes, you can join the line very easily, but it is not passing through the mirror. Why he cannot see R? Are you guys understanding this diagram over here? This is very important.
Sir, can you explain this again?
Yeah, see, have a look. Sir, voice is lagging. Okay, I will repeat. Okay. So this is a mirror. If this is me, then and I am at a distance 5 centimeter, then there will be an image myself at a 5 centimeter. Yep. And as you can see, the ray is passing through the mirror, then I can clearly see myself because I am standing in front of the mirror. Do you all understand my point? But what if I take myself and I shift it slightly left? Okay. That is, now the mirror is actually on its own position, but there is no mirror. If there is no mirror in front of me, can I see myself in the mirror? That's the question. Can I see myself in the mirror? Tell me the answer, everyone. The answer is, of course, no. But let's say if there is an object placed over here like this. So there, the image of this will be formed like this. And now let's join the lines between me and that object. Sorry, like this. So this is me and this is that image. Where is it passing from? It is passing from the mirror. So can I see that image? The answer is yes. Are you all understanding it? Understanding my point?
Yes, sir.
Nimangi, is that clear now?
Yes,
Who asked the doubt, by the way?
Sir, it wasn't me. It was Anushka.
Yeah. Is it clear, Anushka, now?
Yes, sir.
Now, similarly, if I actually like have someone like this, someone over here, of course, their image will be here. And now if I will join it, so it will be joined, but it is not passing through the mirror, and that's why I will not be able to see them. Fine. Okay, this question is homework, similar question. Try doing it, okay? Oh, we have time, so we can do this as well. Okay, fine. Okay, so if anyone wants to answer, you can. Find out the position of the image of an object situated at A, okay, in the plane mirror. So tell me if my answer is right or not. If this is the object, so exactly at the same distance, this will be the image. Am I right? Am I right, everyone? Okay.
Yes, sir.
Second part. So can Paheli at B see this image? Can Paheli at B see this image? Tell me the answer. Anyone who wants to answer. Can Paheli see this image? Yes or no? For that, what do we need to do? We will draw a line and we will join this image with B. Is it passing from the mirror? Is it passing from mirror? Yes, exactly. It is passing from the mirror, yes. And that's why, what can we say? That Paheli will be able to see this image. Yes, yes is our answer. Similarly, can see this image. Yep. So Maruf, you can tell me. Can see or Bujo. This Bujo can see this particular image. Yes or no? What do you think?
Yes, sir.
Yes. Why? Because again, if you will join them, again it is passing from the image mirror. Because it is passing from the mirror, it can see it very easily. Okay. And last thing, moves from B to C. Where does the image of A move? Okay. So if the Paheli moves from B to C, okay. Give me the answer. Anyone who wants to answer? So image will not change. To change the position of the image, of course, what do you need to change? You need to change the position of A. So if this is changing, they will not be able to change this position. Am I right? Yep. So if Bujo is changing the location or Paheli is changing the location, they will not be able to change the location of image. To change the location of image, we need to move the point A. Okay. Is that clear, everyone? Fine.
Yes, sir.
Everyone, please join the quiz. I have shared the link. Quickly join it. Abhiram, present? Abhiram. Adarsh. Aditya.
Yes, sir, I'm
Akshadravi.
present.
Aditya present. Akshadravi.
Yes, sir, joining.
Akshaya. Aliza. Amin. Anand.
Yes, sir.
Anisa.
Present, sir.
Anushka.
Present, sir.
Arnav.
Present, sir.
Sir, is there working out questions in the quiz?
Keyword. What?
Is there working out questions in the quiz?
No, no, no. No numericals.
Sir,
Dia. Yes.
sir, can I leave? I have to go outside.
Okay, fine. Dia.
Present, sir.
Himangi.
Sir, did you mark
Present,
me
sir.
present?
Yeah, I will mark you present. Yeah. Joel. Okay, I'm starting the quiz now. Joel. Krishna. Arnav. Okay. Krishna. Muhammad Muksit. Muksit was there. What happened?
Sir, I'm in there. I'm there.
Yeah, please reply. Maruf is present. Hidash. Okay, Namita and Namrita present. Safreen.
Present, sir.
Sheikh. Yasir is present. Okay, he left. Vamika.
Present, sir.
Varshana.
Present, sir.
Fine. Everyone's done with it? Sir, please explain question number 12. Okay. Question 12 says, what is the angle of incidence? It will be 80 degree. How? Have a look. So if this is 10 degree and the total angle is 90 degree, so if I want to calculate this part, this will be equals to 90 minus 10, which is equals to 80 degree. It? Is it clear now? Who asked the question?
Yes, sir.
Himangi. Is it clear? Yeah. Okay, that's it for today. I will show you the leaderboard. Okay, this is the leaderboard. Oh, a lot of people marked the last question to be wrong. Okay, but okay, that's it for today. We will meet again in the next class. Till then, bye bye. Thank you.